We ask about the meter when it's not running yet.
Yeah. Oh, there we go. Right on time. It's like literally top of the hour. I must have like an con job or something. And we have all is well.
So,
All is good. Feel free. We'll call you if we need you. Okay, we're going to go ahead and get started here. This is the Ledger BOF, a non-working group forming BOF. And I'm going to wave vaguely at the note well slide. If you don't know what this means, go off and research it. Google is your friend. You can also read DCPs 78 and 79 if that's easier for you to remember. But basically, if you're coming to the microphone and have anything to say, it has implications on your IPR and you should be aware of them. I believe we already have a note taker and someone sitting in the Jabber room. So we're just going to start the blue sheets. Okay.
oh,
Yeah, go ahead and make sure your name on the blue sheet.
where's the other one at? Right there. Okay.
Okay. Good.
All right, so here's our agenda for today. So we've gone through the most of the administrivia that we've got. Then we'll have our BOF proponents, Adrian, Evan, and Stephen, come up and discuss the interledger protocol. After that, we'll have just Stephen talk about the crypto conditions and Dimitri to talk about another implementation. And then we'll be wrapping up with asking the questions about next steps and open mic all in a combined set. So some of our non-goals for this session, as we stated, we're not intending to start a working group out of this. After we hear everything, there's something everybody thinks that we ought to go to a working group next, we can start that afterwards, but the purpose of this is not to start a working group. This is also not trying to introduce blockchain as we probably heard about it. Our proponents will go through exactly what they're talking about here, but this is not blockchain. If you're coming in here and expecting Bitcoin or Ethereum, that's not what this is. What this is going to do is, as we said, introduce the interledger protocol in the crypto conditions format. As we said, this is to gauge interest and applicability for the internet at large, and to help us all help the BOF proponents determine how to proceed with the work. But it's not to form a working group immediately after this session. That will be a follow-on. Before we go on, the one other thing that we've been asked is for each of these presentations, their style is very quick, so we would ask that you hold all questions until the end of each presentation, and let them, unless there's some point that you need clarification on, please hold off until the end.
And with that, we're handing it off to Adrian.
Does this work? Yes, it does. Right, so first 35-minute slot is going to cover that agenda. I'll provide some background. My colleagues will go through the problem statement, specifically how we've tried to address that problem, and then some specifics about addressing and routing around the protocol. So background on the project, it's all relatively new. The two of my colleagues who are going to follow me wrote a white paper which they published in October last year, effectively the sort of defense of this protocol for reliable transmission of funds. We established a community group at the W3C around that time as a way, really as a framework to have a community around this effort. What we got out of that was a mailing list, IRC channel, a blog, and we used that as the sort of seeds of getting a community going around what we were trying to do. We've subsequently had 2 community workshops. We had one in San Francisco in February. We've just had one in London, both well attended. The London workshop included a hackathon. Most of the attendees hung around for that and actually played with some of the reference code or started writing some code of their own. Another thing we did at the London workshop is 2 of the implementers attended the workshop and actually demonstrated a real money transaction using this protocol. So 2 independent entities who actually move money using the Interledger protocol. In terms of business adoption, look, it's early days. So you know, this is still heavily in development. We're here to make this group aware of the work we're doing. It's heavily inspired, as you'll see, by a lot of the technology that is worked on within IETF. So we believe it would be of interest to people from the IETF. But again, it is still very early days. So people who are looking at it, using it, are coming to us for advice on how to use it, include obviously Ripple. So I'm from Ripple. 2 of my colleagues are here today. We're building commercial software on top of this protocol. BigChainDB, Dimitri's here, and we'll talk a little bit about their implementation later on. GateHub and Bitstamp are 2 cryptocurrency exchanges. One who allows users to hold balances in US dollars as well as cryptocurrencies. The other allows users to hold euros and cryptocurrencies. They're the 2 who did the exchange last month, where a transaction was actually done from euros to dollars, real money transfer from one to the other. We've had quite a lot of interest, people coming to us asking about the applicability of the protocol for things like transfers between central banks, applicability in interoperability for the sake of digital financial inclusion, quite a wide variety. So a lot of conversations going on, not a lot of concrete implementations besides those that we can really talk about. Finally, there's a lot of interest from people who are looking for a way to incorporate payments into something else they're doing. So just like, the protocol is designed to be a protocol you can build protocols on top of, as you'll hopefully see from the discussion later. And we've got demonstrations, for example, of micropayments to pay for streaming, at least torrent downloads, as an example. So that kind of thing where people are interested in incorporating payments into something they're doing, but are not payment experts and also don't want to tie into a specific payment API. So they don't want to say, well, I want to accept payments, but I'm going to specifically pick a payment network or payment provider. They find Interledger quite interesting because it's open, neutral, sort of agnostic to the payment method. In terms of IP, so when the white paper was released and we thought about the implications of building this open neutral protocol, right from the beginning, the intent was to do it in a process that looks similar to how IETF operates. So there were some patents registered in a separate entity to Ripple, so they're not actually held by Ripple. The intention is for that IP to be held for defensive purposes and obviously made available royalty-free. So there is some IP. It's been registered, but its intent is that it would be licensed royalty-free. Other than that, we've hosted community resources at interledger.org for a good few months. The reference code is there on GitHub. The specifications that we kind of revving pretty aggressively are available either on GitHub or nice rendered versions on the website. And that's probably about it in terms of background on the project. I think I'll hand over to my colleague.
All right. So my name is Evan Schwartz. I'm an engineer working on this project and one of the co-authors of the white paper. So I get to explain to you why you're all sitting here and what we're actually talking about. So what is a ledger first? You all showed up at the ledger BOF. A ledger is just any system that tracks accounts and balances. And payments have always been about ledgers. This shows a very old school ledger where you're tracking accounts and balances and can kind of transfer them between that. But even today, you have the central ledger model, which is that applies to everything from PayPal to a central bank to a bank and more. You also have distributed ledgers like blockchains and things like that. To us, these are all just examples of ledgers. One of the problems is that the world will never agree on one ledger. We've been at this game for a long time, and a lot of people are trying to say, everyone should get on this one ledger. This is the best one. Come and use ours. But then you go around and you say, hey, come and use my ledger, and somebody else is like, well, I have mine. I want to keep using mine, thanks. And we don't think everyone will agree. And so the problem today with payments is that payment networks are disconnected. And they're disconnected in a way that is sort of akin to how information networks were disconnected prior to the internet. So what we're introducing here is a protocol for doing payments across different payment networks. That's what Interledger is. So in kind of quick high-level overview, the Interledger protocol is a protocol for doing transfers of digital assets across different ledgers or payment networks. And what it provides is aiming at the most minimal standard for what different people would have to implement in order to do these transfers across different systems in a secure way. So this is Interledger in one slide. We can all go home now. So I'm going to go through exactly what all of this means, but this is kind of the takeaway. This is the minimal standard that we're aiming at to be able to do payments across different payment networks. So back to the beginning. So ledgers track accounts and balances, but the problem is that not everyone is on the same ledger. So we need to introduce some other party, and we call that a connector. A connector is kind of like a router or a gateway in the internet speak. And what connectors do is they relay and route money. They also convert currencies. So you can pay a connector in one currency and they'll pay out in a completely different currency. And so what the ILP packet or Interledger protocol packet does is basically instruct the connectors what to do. So there's a hierarchical address format and an amount. And you can kind of think of this as an address on a little packet of information, which the sender attaches to a transfer on their local system. You could think of the system on the left as being something in euros, and the one on the right as being something in dollars, for example. So you send a local transfer to a connector, has this packet attached. The connector takes that and relays it on the next ledger, so the recipient gets paid. Now that's kind of too easy. If that were all, then we wouldn't really need to talk about this very much. So the question that naturally comes up when you're talking about relaying money across different systems is, what happens if the connector steals the money, or what happens if it's just down? Can you lose money? Because if the connector fails to relay money, the sender would lose out. So what we use holds to provide security, and I'll walk through that flow. So first of all, it's the ledgers providing the holds. And so you can kind of think of this as like a credit card authorization or something like that, where you go into a hotel and they put some hold on your funds so that you can't spend it in a different way. So the ledgers provide this hold functionality. And so holds are dependent on a cryptographic condition and an expiry. So if the cryptographic condition, which is pre-agreed on, if the condition is met before the timeout, transfer goes forward. If not, transfer rolls back. So these are the other two fields in the Interledger packet. There's the expiry, which is just a timestamp, and this cryptographic condition, which Stefan will explain more of the details of that in the next presentation. So in the flow of the interledger protocol, funds are committed from left to right. So first, the sender puts funds on hold. So they don't actually send the money to the connector, but they say, if you can fulfill this cryptographic condition, you will get this money. So the connector gets a notification that says, hey, they get a notification from their bank or their ledger, whatever it is, that says you've got money on hold for you. So they take that and they go forward that on. They put money on hold on the second ledger. And so the recipient gets a notification. So at this point, no money has actually been transferred, but all the money is put on hold, pending this cryptographic condition fulfillment. So the recipient gets a notification that says, here's some funds on hold for you. If you can fulfill this condition, you'll get the money. So the recipient triggers the execution of the payment by fulfilling the condition. And then transfers are executed from right to left. And this is what that looks like. So a recipient signs a receipt. This receipt format has been agreed upon up front as the crypto condition. They submit that to the ledger, and that executes the second transfer. So the recipient actually gets paid before the sender has actually paid any money. So now the connector's in a position where they've paid out money, but they haven't actually gotten paid. So they have a very strong incentive to pass that message back. And so they get a notification with that same signature or fulfillment. They pass it back. That executes the first transfer, and the payment is complete. And then the sender gets a notification that's, here's a cryptographic proof that the recipient got paid. And so you can have chains that are, so no matter how long the chain is, the recipient will either get proof that the recipient actually was paid or their money back, which is kind of what makes this all work. So in summary, transfers are committed from left to right and executed from right to left. And so this kind of very simple primitive can be extended into very long chains, because as a sender, I don't really care how many hops my money has to go through, as long as I know that there's no chance that it can be lost along the way. And this is this kind of neat trick or new fundamental idea that makes money routable effectively. And so this can enable a network of networks for payments, which is not something that exists today. An open network for this. And all of this is based on this kind of simple packet format. And now my colleague Stefan is going to come and give a little bit more on the addressing and routing that this uses.
All right, thanks. Stefan Thomas.
Clarification question?
Yeah.
Didn't you just say that if the sender ledger faults, for example, the connector will not get paid?
Yes, so we're going to go through the mitigation of that probably after the presentation. There's probably going to be interest. So we have an appendix about that, and maybe Evan will go through that afterwards. But that's correct. Okay, so my name is Stefan Thomas. I also work for Ripple. I want to talk a little bit about addressing and routing. Basically, you saw that little address format earlier. I want to break that down a little bit and explain what's actually behind that. I know you all have 1,000 questions, so just be patient, a few more slides to get through this. The other disclaimer I'm going to give is, I know that there's some people here in the room who have very deep experience with routing. To them, this will seem incredibly superficial and not up anywhere near to the level where the internet routing is at. But I would kind of ask you to consider that this is a very new protocol. We're just trying to get it working at all, and it doesn't need to be as fleshed out as perhaps an internet protocol would need to be. Okay, so basically what we have here is an identifier. We consider it a hierarchical identifier, and it might have a number of different segments. So you can kind of think of it as similar to an IP address, except that it's ASCII, not numbers, and it's variable length, not fixed length. But other than that, we just wanted to come up with a very simple identifier format that we could use as for addressing. One feature here is that you can see that if I have an account somewhere, we want people to be able to create a subledger, and that's kind of to avoid some issues like having to have network address translation type stuff. We want people to kind of be able to extend this network outwards. If I want to create a subledger for my devices or maybe for my kids, I should be able to do that. So that's something that's baked into our address format. So let's actually figure out how this address is being parsed and how the routing happens. So suppose we have a connector, let's call her Connie, The main thing that the connector has to do is they have to figure out what exchange rate they're actually offering between two ledgers. So you kind of saw earlier the two transfers on either side. And so in order to make that transfer possible, the connector must provide some exchange rate. And that exchange rate actually depends on the size, because you could have a connector that has a minimum amount, and so unless you put in a certain amount of money, you're actually not going to get anything out. Or it could have different rates for different sizes. So for instance, if you have a small payment, that might get a different rate than if you have a very large payment. There could be a fixed cost, it could be variable costs, etc. And so in order to encapsulate all this complexity, we came up with this idea of a liquidity curve. So that's basically a curve where your x-axis is how much money you're putting in, and your y-axis is how much money you're getting out. And so that encapsulates, maximums, minimums, fixed fees, variable fees, and even something as complex as an order book. So if you have an exchange market where people are posting offers to trade one currency for another, we can encapsulate the rate information from that as one of these curves. So obviously, if you're trying to start from one ledger and you're connected to Connie, you can kind of ask her, what would it cost to get to ledger B? What would it cost to get to ledger C? And what would it cost to get to ledger D? But that's not that interesting, because what if there's no direct connection, and so we need to actually go across multiple hops? So what Connie will do is she'll actually advertise rates to neighboring connectors, and this is kind of similar to, and I know many people will groan here, but it's kind of similar to how BGP routes are advertised. It's a distance vector protocol, and it's basically saying, like Connie says, I can get you to this destination, and then Carmine will get that advertisement and will say, okay, if this is the cheapest rate that I know about, then I will store Connie as my next hop for this particular destination. One thing that's a little bit different here is that rather than just having one best next hop, we actually might have to store multiple, because these curves, you might have one connector that's cheapest for small payments, one connector that's cheapest for larger payments, and so we have to actually segment the curve and then keep a next hop for each segment. So what I will do, as I think it was Carmine, right? Yeah, Carmine. I will actually take my own liquidity between some previous source ledger and the ledger that connects me to Connie, and I will combine those rates together. So it's actually multiplying the two curves together, and then that gives me a combined curve, which is now the rate that I can get between the origin ledger and the final destination ledger in this example. And then that allows me to construct my routing table, right? So I basically take the routes that have been advertised to me, I add my own routes to it, and I advertise that to the next person. Again, should be pretty familiar if you're familiar with BGP. And then, of course, you get run into the problem, as we all know, that routing tables get very big very quickly, especially with some of the additional data that we need to store. And so we've been thinking a lot about, like, how do we at least tell somewhat of a credible story about how this is going to scale. And so one of the things that we want to borrow from the internet is this idea of autonomous systems, so that we don't actually have routing tables with every possible destination, every single ledger in the world, but rather we kind of route in the right direction, and then someone closer to the destination is actually going to figure out where to get the money to exactly. And then the other thing is we want to have a similar concept as an IP, where you have default routes. And so you can kind of imagine you have these ledgers on the left, and they're not actually participating in what we call CCP, which would be like the equivalent to BGP. And so they're not actually have huge routing tables. They just have a default route kind of going up to this core set. And then you have these more core routers, they know about each other, and then you get to some destination, and now you're basically going down the address with longer and longer prefixes to try to get to the final destination. I want to walk you through that in a second. So suppose we have this destination. We know that for us, like, we're just going to route everything up to our default route. And then once it gets to a connector that actually has a full routing table, that's going to route it towards US. So we're going to get over here. And now this is a ledger, let's say US Wells Fargo, and they're going to say, okay, well, I now need to route to Bob, which is one of the subledgers on my system, and then they're going to route it to bob.car. So you can imagine that there would be a fairly limited size core set, but you could very easily create like lots of subledgers that are attached to that, just like you can have your own local networks on the internet today. And I think that's pretty much it. Just one more note. The address fragments don't have to exist as actual destinations. Again, similar to IP, where you could have a prefix that isn't actually a ledger, but rather just a direction that gets you closer to someone who might actually know about a specific prefix that you want to get to. Yeah.
When you're done.
I think it's about it. Summary. There you go.
Sure.
Shoot.
What connects the advertised transfer rates to the transactions?
So the rate, there's a time lag, obviously, between when the rate is published and when a transaction actually happens. We think that might be addressed in a number of ways. One thing that our customers do, for instance, is honor rates even if they're a few seconds old. Another thing to keep in mind is that exchange rates usually, in the way the system works today, are actually valid for a whole day. So we don't actually worry that much about rates fluctuating that much within a few second period.
What happens if I lie about the rate?
If you lie about the rate, you will look like a unreliable connector. People will want to not use you as a default route and not want to peer with you.
But I just stole $100,000 of your money, so I don't really care very much.
You can't actually steal money because of the conditions. So if you can fail, but you cannot steal money because you can't fulfill the condition unless you actually have delivered the payment to the destination.
No, I delivered some of it. I just delivered a different exchange rate than I promised.
If you don't deliver the right amount, then the receiver will not sign the receipt. And so you will not find out the fulfillment for the cryptographic condition, and so you'll not be able to claim the payment that's due to you.
Okay, so let me see if I can reconstruct this. You advertise the rates, and then I have to honor them as a practical matter because otherwise transactions don't go through?
Yes, basically you can prepare a transaction that's like too small, but the receiver will not accept it as payment.
So if I may interject, I think you're answering the wrong side of the equation. I believe what he's asking is, if a payment connector gives you $10 and then turns around and charges me 100 euros for it, then the condition has been satisfied, but I'm not happy. What prevents that?
So there's kind of two ways to look at it. One is like, what if a connector just gives you a bad rate? So one way to solve that is ask multiple connectors. And then the second question—
I give you a good rate, that's why, because I want the business.
Sure, okay, so I'm a connector and I give you a good rate, and then I don't honor it. So
Yes.
What's going to happen is you, the sender, are going to put a certain amount of money on hold for me. That amount of money is fixed. And so you're going to base that off of whatever the rate that I told you was. But if I then try to take too much of that, what Stefan was explaining was that not enough will end up at the recipient. They will not sign the condition and you will get nothing. And then, sorry, I'm the connector in this one. I'll get nothing. You will not have paid, and then you'll just see me as like this kind of unreliable connector that every time you try to send money fails for some reason, and so you'll try somebody else.
Okay, so the implication then is that the system cannot handle really dynamic exchange rates because basically my rates have to be valid for the entire lifetime of the financial transaction.
Not true, because as a connector, you want to be viewed as a reliable connector. And so if I'm the connector and I'm giving you exchange rates that are like just the very, exactly what the current exchange rate is, and there's a lot of fluctuation, then after some reasonable amount of time, you'll come and you'll want to do a payment. And it won't work because I'll say, oh, sorry, that's no longer the rate. And so again, I'll seem like an unreliable connector to you. So there's an incentive to basically, what I can do is build in a little bit of a buffer. And so if I give a little bit of margin, then I can account for the fact that exchange rates might shift. Does that make sense?
I understood it.
I would just ask, first of all, that we are asking for clarifying questions on these slides, and if you can state your name.
A clarifying question here.
Actually, I'm Kevin Fall, CMU, but it's a little bit more than clarifying, so this is not the right.
Well, yes, please hold it for the end then.
No,
I think we're
Well,
yeah.
you're all right?
Well, I have a clarification question on the right here. Name is Alain Durand from ICANN. Could you please go back to your slide where you have the names that you're using?
Just stop.
Okay, thank you. That's one again. Oops. Thank you. Could you tell us a little bit more about the structure of your namespace? So I understand you read it from the left to the right, and who is assigning those different labels?
So that's actually a really good question because that's one of the places where I would say we're trying to slightly diverge from what the Internet Protocol does. So in the Internet Protocol, as we all know, there's IANA and numbers are actually assigned. In this case, what we're doing is we're basically saying that you could pick a name that collides with someone else's name, but what will happen is that connectors will pick one or the other interpretation. And so if you pick someone really popular and you pick their name, your payments will just fail. They will just not get to you. They'll go there, and no one there will be able to fulfill that particular condition, and so they'll just time out. And so you've actually not been able to achieve anything, neither disruption nor any benefit to yourself. So we anticipate that what people will do is they'll pick unique names. And as a result, you will basically see connection or routing tables sort of evolve over time based on that.
So that will be on the right-hand side of your names, yeah? But on the left-hand side, like US or WF, do you expect to have an organization that will give out those names?
Yeah, so I think that at the top level, you'll see what I just described, which is basically sort of a, you just put something out there. Any name that's not super well known won't work as a top level. But with under the top level, I think that names will be handed out. So for instance, there might be an authority for the string US or like generally country strings, but you could also have a top level string, let's say Bitcoin. And then that would just be whatever people consider to be, quote, Bitcoin.
So there will be no coordination between those identifiers?
Hopefully not. If that doesn't work out, we'll fall back to something more akin to IANA, but we want to give it a shot to see if we can do it with that.
Okay. And also, have you considered the potential of leakage of this into DNS or leakage of DNS into this and collisions there?
So I would kind of take a step back and say, this should be thought of similar to how an IP address works. So we are concerned with prefixes. We're concerned with having a good enough interpretation that we can get the packet routed closer to the destination, less concerned with uniqueness or like having these identifiers be persistent, etc. Because you could have a different identifier that resolves to this, and this could change rapidly.
We have seen an example of, for example, people doing APIs with names like this, and for some weird reason, it ended up going into the DNS.
Yeah, I mean,
like everything ended up going into the DNS, essentially.
You mean like these names would end up being valid domain names, or? There
might be some collision where those names will be sent as DNS requests to the root, and then you have all kinds of weird things that can happen.
Yeah.
Right.
So I think we're getting a little bit off into the weeds here. These are all design decisions that certainly if the work were to move forward somewhere, they might be revisited. I don't think it's necessarily worth digging all the way down to that level right now. So if I'd like to go ahead and move on to the next question.
Dan Rutzer. Quick clarifying question on the holds. So the holds are not held by the connector, is that correct? So how do you guarantee it? In a very simple analogy, this is like escrow, but in escrow, you actually have a third party that keeps the holds. So how can you guarantee that the money that was put on hold, I mean, the entity, Mary or whatever was on the right, is actually not going away. So in that case, the connector is losing money. I can make a very big transaction and then go away.
Yeah, so in the paper that we wrote, we actually did describe this functionality as escrow. One of the reasons we've started talking about it as holds as opposed to escrow was escrow has a lot more connotations to it. But you can think of it either way. And you can think of it, so if you want to talk about it as escrow, it's actually the same party that is providing the ledger that provides the escrow service or this hold functionality, with the idea that the sender and the connector don't trust one another. They don't know who they are. They don't want to know. But for example, the sender has an account with the ledger on the left, and so they trust that ledger, whether it's Bitcoin or whether it's a bank. And the connector is someone who has an account on both ledgers. And so they trust both of those to hold their accounts, but again, they don't trust the sender or the recipient. So the idea is you should only have to trust your own ledger that you have an account with.
Great. It would have been great just to display the fact that it's in the realm of the ledgers. But yes, makes sense. Thank you.
Jason Nichols, question for you about the conversion rates and the optimal paths. So in the case of, can you guys put the conversion slide? Sorry.
One of the ones earlier in the deck or later?
It was the earlier one on the deck with the curve. Yeah. There. So in the case of like a chain of these, the shortest connector from A to B is not necessarily going to be the cheapest connector, and actually incredibly unlikely to be the cheapest connector from A to B. Longer, more diverse paths are much more likely. So going from A to C to D, back to B, I mean, arbitrage in the finance industry is pretty well known, especially in currency exchange. So how do you guys handle that kind of a situation where the direct path is virtually guaranteed to not be the most efficient?
Right. Okay. So there's kind of two questions in there. One is, as a clarification, we don't actually route by shortest path. We route by cheapest path. So basically, as we broadcast these curves, we will find, like, for any given point. So let's say you're trying to send $10. What is the most euros that you can get at the very other end, based on all these curves being added together?
So just to clarify, then, that's depth first search across the entire network.
No, it's a distance vector protocol. And what we're using as the routing metric is a curve as opposed to a number, a scalar. And then, I forgot the second answer.
So Colin Jennings, affiliation Cisco and Bitfury. When you're doing this routing table and that distance vector, I'm sort of wondering how often you expect a given conversion point to change its exchange rates. Like, effectively, how often are they updating the routes? And then I'm right in understanding that would possibly propagate across the whole network, right?
So that's definitely an area where we lack, practical experience. So right now we've only been testing, simulating. And so in our reference implementation, new rates are broadcast every couple seconds. And then they, takes a few hops until they propagate to a further away connector. But after something like a minute or so, most connectors have heard about the new rate. Whether that's practical, I have no idea.
So can we flip to the other slide that just had the basic flow, like beginning through to end? So on this, yeah, sure. On this one, how quickly are you expecting the green person on the right to effectively sign the receipt and confirm the whole transaction? How long do they have to do that type of thing?
It's a good question. And so that's basically, it's variable. And so what that varies with is when the sender wants to send a payment, they have to ask the connector for a quote. And so part of the thing they have to ask for is how much time they want the recipient on the other end to have to sign the receipt. And the reason they have to do that is because the connector will have to put money on hold for that duration plus the network delay and things like that. And so the longer you want the recipient to have to put on hold, most likely the more expensive it's going to be, because the connector is incurring some cost for putting money on hold.
So how do you deal with people that just put it on hold for, let's say, an hour, sit over there, wait on it for 59 minutes, and if the currency has migrated in their favor, run the transaction and keep the money, and if they haven't, like, just, cancel the transaction?
So these are, like, practically, that's something that we'll figure out. But one of the ways to kind of address this is just like, because we're building a payment protocol where you can pay anyone, connectors could expect fees from you. So if you want, it's like, sure, I'll put money on hold for you if you pay me. And so you may have to pay some little bit of money.
So I don't think your routing protocol, though, supported that fixed fee, right, in the way you described it.
Just one real quick administrative interrupt. We do want to get through all the presentations, and we have some open mic at the end. I'm not telling you to stop. I'm just saying I'm cutting the microphone after Andrew, and we have someone over here. Thanks.
I do want to get a quick comment in there. So one quick comment on the receiver. So we don't assume that the receiver has to be the actual receiver. It doesn't have to be your phone. It doesn't have to be something like that. It could be a server that's receiving on your behalf. So it could be something that's faster and more online. The other question regarding the hold time. So because of different hold times, and you might have different fee structures for that, we would basically need different dimensions in the routing protocol. So probably what is most likely is there'll be one or maybe a small number of standardized sort of max hold durations that people are quoting for. So let's say 10 seconds and 3 days. And you have to kind of fit into those buckets. That's the only thing that we've been able to come up with so far.
Thank you.
Just a follow on when you talk about the volatility of the exchange rates. You'd previously mentioned the concept of an order book. So I'm not sure if you guys are familiar with the timescales that order books operate on, because it's microseconds, not days. So if you're going to be propagating new exchange rates, I mean, would that cause a problem with the exchange rate propagation throughout the network if you have to change for like the national best bidder offer updates literally every microsecond?
Yeah, so the exchange rate propagation has a lot of sort of smoothing aspects in it. So you saw those curves. We actually simplify those curves, take out points that are not adding much detail. We are also not updating on every order. So we have, for instance, we have an internal order book implementation which can do 14 million trades per second. We don't update the routing tables 14 million times per second. We just update when there's a significant update.
So real quick, we're going to take this microphone next. Thanks.
Okay, thank you. Stephen Wright, just in the case where you have a sequence of connectors, normally in a financial transactions, you have some sort of concept of an audit trail. So is there visibility of the sequence of connectors tracked somewhere? I mean, from the explanation, it wasn't clear that even the final party knew of the existence of all of the connectors along the path.
So one of the things we're trying to do with this is kind of learning from the history with IP is trying to make the core protocol as simple as possible. And so there isn't necessarily an audit trail built into the kind of this very minimal standard. What we do expect to have happen is have lots of different protocols built on top of the core interledger protocol. And so one of the things that's quite likely for, and one of the reasons for this is that the kind of trail and the kind of information you want propagated very much depends on, for example, the size of the payment. Like if you're sending $100 million around, you very much want to know who all the participants are. If you're sending, micro cents or something, you may want a lot, like privacy may be a much more important concern than like having this kind of audit trail. And so what you can do with this is build protocols on top where the different participants can say, in order to facilitate a transfer for you, you have to first tell me a bunch of stuff about who you are, why you're doing this, things like that. And so that's the higher level protocols that we're also working on top of this.
Also, one comment that all the payments can travel with a memo field that can be structured. So you could have a portion of the memo field that's dedicated to providing enough information that connectors will feel comfortable relaying the payment. But obviously there's this pretty big like privacy versus, anti-money laundering, et cetera, trade-off. And so we anticipate many heated debates about what exactly goes in there.
Andrew Allen, just make a comment on this one, and then the other point I was going to make. I think Adam and I had a little discussion beforehand. So, there's a lot of interest from governments in money laundering, that kind of thing right now. So, I think you will need some trails, and it can't just be under the control of the end user. There probably needs to be some record. But then I'm just going to make another point. So I've actually someone who has actually transferred a significant sum of money using Oanda, which is a currency trading firm. They used to offer this service where you could trade for just a fixed fee, a small fixed fee, quite large amounts of money. And with regard to the exchange rate change, as I recall, it was you had about 60 seconds to commit to do the transfer. So it seems that it doesn't have to be that quick, at least in the commercial services as they have existed up to now. That they'll give you about 60 seconds, even though the international rates are obviously changing faster than that.
Yeah, that's definitely consistent with our experience as well.
Thanks. So there were 18 more slides in the deck y'all didn't get to. Are those backup material?
So while we were talking before, somebody asked a question about wouldn't the connector lose money? So I'll run through that appendix. We want to talk about risks and mitigations for those. These are the slides that Adam is keen to have us present. So
I don't care one or the other, the slides.
So one of the things that the Interledger protocol guarantees is that the senders and the recipients are isolated from risk no matter who else is in the chain. Their ledger enforces this hold that says either you will get this cryptographic receipt or your money back. So the senders and the receivers are isolated from risk. However, the connectors that fail to pass on the fulfillments may lose money. And I'm gonna go through why and then also what they can do about that. So back to that flow that we had before. So the recipient signs the receipt. So that fulfills this, that executes this transfer on the right, but the connector has not actually gotten paid yet. And so the question is, what happens if they fail to pass on the fulfillment and that other transfer times out? Well, that would mean that that connector loses money. Well, that's not great. So there's 4 mitigation strategies that they can use. There are at least 4 mitigation strategies. So one of them is redundant ledger connections and connecting more reliable ledgers. So that's basically like, as a connector, you get to pick which ledgers you're connecting, and you have this incentive to have as good a connection as possible to those ledgers. So what that could look like is lots of redundant private lines that are not going to be disrupted, or different communication channels, etc. If there's a ledger that is very unreliable or sometimes down, doesn't always send you notifications, you may either not want to charge, you may not want to connect that ledger, or you can do the third one, which is pricing risk into the spread. And so connectors can make money off of the difference between how much they're getting paid and how much they're paying out. And so if there's a ledger that's very risky because, you know, it's unreliable, sometimes its connection goes down, or the servers itself go down, you might price that in and actually just charge more for it. So that creates an incentive kind of for everybody to have more reliable systems. So that's another thing. The final one is incentivize retries. So one of the interesting things about Interledger is that it enables payments to actually be retried. Today, if you sent like a wire transfer and the money just kind of, you know, got lost or something, you wouldn't want to retry it because that's more money coming out of your account. However, in this case where the sender sees the money return, so this is that case where the first transfer timed out and the connector lost money. So the sender sees money return, but they actually wanted to make a payment. They didn't want the money to sit in their account. So what they can do is just retry that payment because they haven't actually sent any money. They put money on hold for a couple seconds, timed out, came back to them. So now they're like, you know, I wanted to make the payment, so please make this happen. And so if they send it again, what can happen is the connector is notified of new funds on hold, but with the same cryptographic condition as before. And so instead of actually forwarding the money on now, they already know the fulfillment to that condition. So what they can do is just pass on that fulfillment that they got before, that executes the transfer, and then everybody is happy. And so in multi-hop payments, connectors are actually incentivized to retry through the same route, because if I'm a connector and I'm sort of dealing with others, I would probably offer a cheaper rate to another connector, or advertise a cheaper rate to another connector if I know that, given that there's this risk, if they would retry it through the same path and allow me to reclaim the money if this does happen.
Erica Squirrel, this is probably a stupid question, but why do fulfillments have to time out? I understand why the time out on the forward direction, that is, you have to fulfill the condition, but why can't I send the fulfillment essentially indefinitely and then hand it over?
So let's walk through that. So you're the sender and I'm a connector. So you put money on hold indefinitely for me. Now I don't do anything.
Mm-hmm.
Nothing ever happens.
Mm-hmm.
You've just locked up money forever. That's not great. So basically, as a sender and as kind of all of the participants, you don't want money being locked up indefinitely, and so it needs to have some kind of timeout.
But that could be quite long, right? I mean, compared to the transaction itself, right?
It could be. The problem is just as a connector, as kind of any party in the system, as the connectors, you would want to expect that somebody is trying to screw you, for example, and you would want to price it such that you're assuming it'll take the maximum amount of time that it has.
Okay, thank you.
Yeah.
Thanks. Okay, so now we're going to talk about the actual crypto conditions part of this. Are you doing that one? Okay.
Sweet. All right, so anyone who's coming for cryptography, your wait is over. So we kind of mentioned how cryptography is used in Interledger. I want to go through a couple ways in which it's not used, or at least not on the Interledger level. Namely, it's not used for authentication. We assume that authentication is between ledgers and their account holders. So if you use Bitcoin, you sign with Bitcoin's cryptography. If you use your bank, you use TLS. So whatever the ledger uses to communicate with its customers, that's up to them. That's not part of this at all. However, there's one place where we do need cryptography, which is we need to know when these holds execute. And so basically, what is this thing that appears in all the slides that apparently fulfills these conditions? And so, cryptography, it's been around for a while. I'm not going to go through why we would use that, but basically it allows us to perceive the outside world without necessarily having to scan a receipt and interpret whether that is right. Like, obviously, we want to use cryptography with this. And so the simplest option would be just to use a simple signature. So you have some, let's say, receiving bank institution, and they are just the ones signing a receipt, with their cryptographic key, and we're done, right? But problem is that, someone at that bank might compromise that key. And so it's actually kind of a trend that we've noticed in the banking world that people are wanting to move to more secure solutions, one of which is multi-sign. And some of the things that are driving that are things like this. It's not ideal, losing a lot of money just because there might be some bad instructions that have gone out or some inside help. I'm not saying that this is necessarily the right theory. There's a lot of different theories about what happened in this particular case, but we're hearing from our customers that they want more secure solutions than what some of the existing networks are able to offer. And so we want to think about how we can do better. And so one of the things that people do whenever there's something very highly secure that you want to be very conservative about, they tend to do some sort of multi-sign. And one example would be the root DNS zone for DNSSEC is being signed by multiple keys. And so you can kind of imagine you have a situation like this. And so it protects both against a malicious attacker as well as someone losing their key or the key getting lost. So we can still sign with the other key holders. So pretty basic. And so we can kind of imagine, okay, we want these two things, right? So we want to be able to have signatures and we want to be able to have thresholds. But as we were working on this, we noticed that for the threshold side of things, it's actually not too hard to do this. So basically just say, like, rather than having a threshold type of signature that has multiple signatures in it, why don't we just make it a threshold of what we now call a crypto condition? So like of either another threshold or a signature. And it actually doesn't add much complexity, and it enables some new use cases. So here's an example again from IntelLedger. So you have a receiver, and they have 3 signatories with a 2 out of 3 multi-sign. And now there's a mode in IntelLedger, which I'm not going to explain exactly what it does, but it's called atomic mode. So basically, when a receipt is generated, it's notarized by another party. And in this case, we assume that notary is another multi-sign. And so we could just trust the notary signature, but then the notary could completely lie about the outcome of the payment. So they could actually say the payment has succeeded, even though they've actually never seen the receipt. So it's a bit nicer if we just combine them with another threshold to say, okay, we have both the receipt and the notary has said that it was in time, so now the condition is fulfilled. Okay, now kind of backing up a little bit, there's been a lot of similar work out there. One thing I want to highlight is Bitcoin with its scripting language. So that has multi-sign in there and actually allows several levels of multi-sign if you want to. But it's basically a whole Forth-like language. So it's maybe a little bit more complicated than what we want to build into our standard. There's also a number of RFCs that have multi-sign related stuff that we could find. But usually it's always just the ability to express multiple signatures, not necessarily describe how many you need for this to be valid. And also, crucially, in my opinion, it doesn't provide structured keys. And I want to explain what that is and why we think that's really important. So suppose you have someone named Bob, and they want to give a key to somebody named Alice. But now, let's say you want to switch to multi-sign. And so rather than just having to give Alice a new key, they have to explain to Alice that now she has to validate signatures differently. She has to actually consider multiple signatures. She has to make sure that the threshold is right, etc. And so it'd be interesting to have a signature scheme where it kind of exposes the same API as any other signature scheme, like RSA, ECDSA, etc. But it actually has structured keys so that each key can be actually multiple keys in some arrangement and so on. So this is basically our attempt at creating something like that and imagining what that would look like. Here's some more things that we looked at in terms of other work that's out there. So these are all links. So if you get the presentation, you can check all of these out. And there's also been calls for standardization. So from a recent event held by the United Nations, ID 2020, Chris Allen has been talking about this and basically saying that there should be a standard for this, something that allows you to express these types of what you call smart signatures, basically signatures that can decompose into different cryptographic primitives and other rules, etc. Okay, so the biggest question that you immediately pose yourself is, you can go from a single signature, which is what we mostly use today, to some sort of Turing-complete programming language that's in there, right? And probably what you want to do is somewhere in the middle or somewhere in between. And so with the single signature, we kind of already talked about that. It's not really secure enough for what we want to do. And if you make it a full programming language, you're probably creating a pretty large attack surface, potential for bugs. I want to highlight one particular issue in our use case is we want to make sure that all of the conditions are interpreted the same way, because otherwise we can get this situation where one ledger considered this condition to be fulfilled and one ledger considered the fulfillment to be invalid. And so now we have a very big problem, because now it's not the connector that screwed up, it's someone that screwed the connector, which is no good. So we want conditions to be interpreted the same way. Either both ledgers have to reject them or both ledgers have to accept them. So what is that optimum complexity that we should aim for? And so I want to make an argument for sort of a scope which I call delegation. So basically the idea is that if you wanted anything more complicated than just multi-sign, then you could have somebody interpret all those rules and then sign something for you. And then even if you wanted the security level of having multiple independent parties where no single party can screw you, you can still do that same thing, just have different people run that code and sign it for you. So signatures actually allow us to encapsulate logic. And any example that you can throw at me, hopefully, we'll see in the question section, but can be addressed with this kind of scheme better than by building a Turing-complete language directly into the standard. So basically, the general form of this is you have these inputs, which could be signatures. We also have a few other primitives in there, but they basically are conditions that either return true or false. And then we combine them with thresholds in order to get one final result that's true or false. And so that allows us to express any kind of delegation structure that we want, any threshold, any set of thresholds, etc. So here's kind of the proposal. There are 3 implementations. One of them is in progress, depending on whether Jehan over here find some more time. But there's a Python implementation from the guys who are going to present next. There's a JavaScript implementation from us. We probably are going to do a few more languages as well. And then there's a Go implementation. So here's what one of these crypto conditions actually looks like. So it's kind of a URN. Probably should have the URN prefix, maybe, whatever. Well, you'll tell us. It starts with this fixed prefix just to indicate it's a crypto condition. It has a type field. I'll explain what the next thing is. And then there's a hash, and then there's a final field, which I'll also explain later. Here is the ASN1 if you wanted to express a condition in binary. We actually use ASN1 for describing the abstract syntax because it allows us to prove that we don't have any holes in our syntax, and also allows us to precisely define what the possible values are for all the different fields. We don't, in the current version, use BER/DER because I think it's universally hated. It's a fairly complex encoding format. I could be convinced by more experienced people to switch to BER, but what we currently use is OER, which is a more recent set of encoding rules for ASN1. It basically is simpler, a little bit harder to shoot yourself in the foot, a little bit faster to parse, so it made more sense to us. It's a recent ITU ISO standard, but yeah, totally open to other suggestions. Here's what a correspondent fulfillment looks like. So just to recap the terminology, so a condition is basically like a fingerprint of a public key. And a condition is a fulfillment is basically like a signature. So if you have a condition and you have a fulfillment, you can verify the fulfillment against the message by saying, like, does the signature match this message? And you can also extract the condition from the fulfillment to basically say, does this match the public key that I was expecting, or the fingerprint of the public key that I was expecting? Here's the format. I think I'll probably go through this pretty quick unless we have questions. Here's a threshold example. So one quick point here. So when you have a fulfillment of a threshold circuit, you don't actually have to include the branches that haven't been fulfilled. So basically, when we do a threshold condition, the condition is just a hash of the subconditions. And so in order to regenerate that hash, all we need is those hashes. And so if there's a subtree that might have, hundreds of conditions in it, and none of them are fulfilled, or maybe some of them are fulfilled, but we don't care because we can fulfill the overall condition just by having the other branch fulfilled. Yeah, we can skip that entire part and just replace it with a hash, and the overall fulfillment can stay pretty small. So again, that's sort of a nice feature. This little field in the beginning, I promised that I would explain it briefly. So that's the bit mask. The way that works is each bit stands for a cryptographic primitive or feature. I probably will skip this point just for time. If there's interest, I'll come up to me afterwards. And then there's another field at the end, which is max fulfillment length. So that's basically what is the maximum size that a fulfillment could take. And so that again prevents this this issue where one ledger might accept it and one ledger might not, because now we know so I should first explain. Ledgers might have different processing capacities for what size conditions that what size fulfillments that they can process. So let's say you have one ledger that's like a blockchain, it's very resource constrained, so it can only handle fulfillments up to 1 kilobyte. So basically what it would do is it would say, when you give it a condition that has a max fulfillment size of greater than 1,000, it would immediately reject it. So you would never get through the prepared stage in an interledger transfer, for instance. So it basically prevents you from getting a nasty surprise later where one ledger says like, oh, this is too big, and another ledger says, oh, this is valid, by stating the size up front and making sure everyone supports that size. I'm gonna skip this. Terminology, we talked about this. So this is a very extensible standard. So each condition is basically completely self-contained. So we're basically, depending on what the number is after CC, the rest is completely up to the condition to define. And so you can add new types of things into this. Subdelegation would be, I have a key in there, but I can, instead of signing something, define another key that can sign it. So you can extend it like that. And this sort of general framework of having a hash of hashed fingerprint to express what the tree looks like, and this size and the bit mask allows you to maintain all the properties across any type of condition you'd want to have, even a Turing complete programming language if you so choose, although I wouldn't recommend it. So just to recap, it's a standard for composable signatures. It looks on the outside just like a signature scheme. You can validate the public keys are correct. That's really important because we want to make sure that when we get a signature, we can actually verify it. It's composable, so you can take a public key, use it in a threshold. You can take that resulting threshold key, use it in another threshold, etc. It doesn't matter to you what keys other people use. So whether they use a single key or a threshold or other combinations of primitives, it doesn't matter to you. You can just treat it like a key. It is extensible, upgradable, so if better crypto algorithms come out, we can add them. And also it's pretty efficient because we can kind of prune any branches that are not actually being used. Here's some open questions, and kind of curious to hear what you guys' questions are.
Yeah, Jahan Trebek, I did a Go implementation. I still think that I wonder about there being these two encodings, the printable encoding and the binary encoding. I think that should choose one because having support for both makes implementations more complex. And I'm not sure about the value of the printable one. I feel is not actually that human readable.
Yeah. Okay.
Quick comment and a question. I'm Yaron Sheffer. So I actually read the draft, and the presentation is so much better at presenting the background than the draft. So thank you. Please add a few paragraphs to clarify what's going on. And then a question about scale, and this actually applies to both this presentation and and routing. You sort of assume that your routing is between financial institutions, but then Bob does have his own, whatever it's called, subledger or whatever. So would it make, if everything is absolutely successful, would it make sense for Bob to have his own ledger so that he can get the best rates? And if so, how would your routing protocol handle it on the one hand? And then on the other hand, you're doing all this fancy multi-signature stuff. That would probably not apply to poor Bob. He will just want a simple signature. So the rest of the thing is over-featured for Bob.
Yeah. So I'll address the second question first. So if you want to implement crypto conditions, you can actually implement a subset if you only expect to be needing a subset. So for instance, Evan is working on a protocol that is what we call a transport layer protocol. For you, it'd still be application layer on top of Interledger, which basically sets the conditions up for you. And in this particular protocol, it only uses pre-image conditions, which are basically just hashes like SHA-256. And so you could have a crypto conditions implementation which only supports that condition type and nothing else. And so the sender and receiver libraries can stay extremely small and simple. You don't need to understand everything. And then the other point about scalability. So I guess for the crypto conditions, there is sort of a scalability ceiling where like, okay, if everyone uses these gigantic keys that could have huge fulfillments, eventually you'll run into somebody's maximum fulfillment size. But we think that there's enough room for it to be useful before that happens. One comment on Interledger using crypto conditions, you don't actually add more to the condition as you add more hops. And then the final point around routing scalability, if Bob makes a subledger, everyone else doesn't need to know about that at all because Bob will just prefix his own address to any address on his subledger. And so everything will get to him in the first instance, and then he can know how to route it more specifically, very similar to what you would do with like IPv6, where you have a prefix, it gets to you, and then you know where you want to forward that to.
But then is Bob still reliant on Wells Fargo, or can he use any of the other? So Bob will be incentivized to create his own, I don't know, his own ledger or his own way of choosing between multiple ledgers.
Right. So that's why we, for very similar reasons as to why you don't publish your IP address as an identifier, we don't want ILP addresses to be used as identifiers. They're purely like routing tags. So if I want to switch from Wells Fargo to somewhere else, all of my ILP addresses will change, but it shouldn't matter because I can just map my whatever my actual identifier is to a new ILP address.
Okay. I just wanted to add one point about the complexity and with different algorithms. So one of the really key features of this standard is the fact, or this proposal is the fact that you can check before, just with that condition, what types are going to be in it. And the reason why that's really important is because we want the standard as a whole to be able to grow and add new types of crypto algorithms. However, you also want to make sure that you don't try to submit a crypto condition to a system that won't be able to handle it. And so the way that you can use that type prefix is basically before you submit the condition to some system that's going to be expecting it, it will check whether that type bitmask contains any types of conditions that it does not support. And so if the condition does, then the system can reject it without actually knowing what the full signature will look like.
And just to make sure there's no confusion, there's a type field, which is basically which condition are you using. And then there's a bit mask, which basically is necessary because some of the conditions, let's say you support threshold types, but you still need to know all of the possible types that could be somewhere within that threshold tree in order to know whether you can validate the whole thing. So the bit mask actually tells you everything being used within a condition, not just a top level type.
Are we in the open questions or not?
No, we have one more presentation. We're going to have someone come up and talk about implementation experience.
Kenny Patterson. I'm kind of interested in the PKI that you're assuming is sitting behind all of this, because you've got signatures flying around left, right, and center. Signatures need certs. Where do they come from? What's the liability model? How are you handling revocation, et cetera, et cetera, et cetera?
Yeah, so as I said before, this is something that actually, very good question, I should say first. So this would be something that lives on the level of a crypto algorithm. So you could use X509, you could use JWT, and just use this as one of these supported algorithms. And it would internally break down into more keys and things like that. But to the outside, it looks like a regular crypto algorithm.
Like where we.
No.
Is that a good wow or a
quick follow-up? That's not really how PKI works, but.
Well, I mean, you could have a certificate, and you could say that this is your key, and you put the condition.
Right. So, yeah, Rich Saul. So the question I think is, I got a key and it's signed. How do I know that that's a legit key for the entity that is relying on it?
Well, again, so in the case of TLS, for instance, you might have a certificate that's issued by a certificate authority, and then the key that's.
I understand how certs and CAs work. I'm wondering how that mechanism ties into what you've got.
This would be the key. So you would say, like, my key is of type crypto condition, and here's its fingerprint. And so if someone is using that, you can use that. Like, yeah.
Okay, so my key is a cert. Okay.
I think I understand what's being proposed here. I mean, is it an accurate restatement to say that this is like
Name.
like Richard Barnes? So like when you establish a TLS connection, you know that you're talking to the holder of the corresponding private key for that public key, right? So
actually, sorry to interrupt. Maybe it's easier to use JWT than TLS because TLS does a lot more than just signing.
Sure. You verify a signature on a message, right? You know that the holder of the private key computed that signature, right? Doesn't say anything about what that public key is. There's an entirely separate, independent operation to figure out whether what you associate with that key pair, right? So I think what he's saying is you get one of these things, you get the fulfillment, and you know the collection of public keys that were involved in this. And so you know the holders of the corresponding private keys contributed to the generation of the signature. And then it's an independent operation to figure out what you associate with those key pairs.
Sorry.
Yeah.
So I think maybe let's try. So the way the fulfillments are crafted, right, is that I send you a transaction request, and it's got we'll just say one signature is enough. It's got a public key in it, and then you fill it by signing, and then the terminal ledger fulfills it by signing with the corresponding private key, right? So I think the question that Kenny's probably trying to ask is, how do I obtain the public key that I expect to shove in the transaction?
So
and how do I validate it?
Right. Okay. So I'll answer that in the context of ILP. So in the context of ILP, we imagine there would be a stack of protocols. ILP does not deal with that any more than IP deals with encryption, etc. Okay, and then you have application layer protocols on top, which negotiate things like how much money to pay, who to pay it to, what the ILP address of that person is, as well as what condition proves the fulfillment of that payment. So just to give one concrete example, Adrian is involved with the W3C web payments effort. And so in that case, it would be the browser exchanging with the web server what the destination should be and what the condition should be. And then by the time it's handed off to the ILP stack, the condition and the destination are already set. You're already decided through some higher level protocol.
Yeah, so I was going to comment on the W3C stuff, but I guess the key point here is by the time you get to the point where the sender is constructing the packet that they send off, which contains the address of the receiving account and the timeout and the amount, they know what the condition is that they must put in there. So the protocol itself, this layer of the protocol, doesn't define how they get that. So they have a condition they're putting in there that they're sending off. Somehow they have established from the receiver what needs to be in that condition. And that could be a myriad of ways. So it could be as simple as the receiver said, here's a hash, use that. Or the receiver said, here's my public key, use that. This layer of the protocol doesn't define how you verify that the receiver is giving you the right value. That's layered on top.
So just real quick, Administrator, we have people here from a lot of different areas who probably don't know each other. I'm going to remind people when they come to the microphone, please do say your name.
That was Adrian Hope Bailey from Thanks. This is Richard Barnes from Rizal. Yeah, so kind of following on a bit to Adrian's question, I was wondering if you could maybe comment briefly on kind of what role this technology plays in the overall system we were talking about in the last period. So we kind of started with this big picture routing thing, and we drilled down to a very specific component. Can you maybe provide some of the connection for how this plays in that bigger system?
Right. So crypto conditions would be used within for the purpose of determining when a hold is fulfilled. So you have ledgers, they would have a feature if someone puts money on hold and then provides the fulfillment, the money will move forward. If they don't provide the fulfillment time, the money will move backwards. And so that's where we use it primarily in ILP. Within the larger ILP world, it could be used in a number of ways. It could be used by ledgers to do authentication if they want to do that. But that's kind of further use cases beyond what we're talking about right now.
Thomas Teddy, Mozilla. I have a question. Is it a requirement for these fulfillments to be uniquely identifiable? In particular, I'm thinking ASN1, I'm not sure what your exact encoding, but often encodings have multiple representations, and this has caused some sadness to Bitcoin users in the past.
Yes. So thanks for that question. So for most of the ILP use cases, we care about deterministic evaluation, not necessarily canonical encoding. We are using a form of encoding rules for ASN1 called canonical OER, which are canonical, but we technically don't need to.
Okay, so also if I were to have to determine the status of the current transaction I've submitted and retrieve all the possible fulfillments, I basically have to parse, and I have to be able to identify those. I have to parse the fields and make sure they're equivalent.
Yeah, you basically, what you do with a fulfillment when you receive it is you do two things. You want to make sure it matches some condition that you're expecting, and then also you want to make sure it's valid with respect to some message. And depending on the crypto algorithm, so for instance, in the RSA crypto condition type, you actually have to include the public key with the fulfillment so that you can hash it and find out what the condition is. That might make the scheme horrible for some use cases. That's one of the things that'd be good to get more input on, because that means that with every signature, you're basically including the key, which could be pretty big. But you basically know how to get to condition from the fulfillment. That's kind of the invariant that we need for keeping this nice and composable and the conditions constant size. Should we go into the next presentation?
Thanks, yeah.
Okay.
Hi, my name is, let me first go. My name is Dimitri de Jonge. I'm working at BigchainDB, used to be Scribe.io. And basically, when we started creating BigchainDB,
Can you move a little closer to the microphone?
Closer?
Yeah.
Like this close? Up close?
Yeah, that's good.
Yeah, perfect. So for BigchainDB, we kind of want to make a blockchain that has the look and feel of big data database. So these are some design targets we put up front, and basically you want high throughput of transactions, and more importantly, we want to have the look and feel of database, meaning that you can create asset types as you like. Why crypto conditions, interledger, and the entire stack you just saw is important to us is because we want to create a part of a stack for fully decentralized developers. And basically this means our system needs to be interoperable with other systems, other ledgers, other kind of decentralized databases. Now, when we talk about assets, we don't only talk about cryptocurrency, we also talk about things like energy, could be any kind of valuable asset like gold, diamonds, could be title, could be tracking of goods, could be licenses, stuff like that. So having a system like Interledger allows people that use our system to define their assets. If the assets are fungible, they can be traded against each other. And in order to have a trading system, you have to be able to open up your ledger to connect to other ledgers and have exchanges in the middle. And that's exactly what Interledger provides. We went a bit more deeply into the Interledger stack, and we figured that crypto conditions is a nice way to express the scripting language that's connecting transactions to each other. So basically, an input and output script, like for example in Bitcoin world, would be conditions and fulfillments. Somebody that says a public key has to sign this transaction, which is an output script, would be a condition that contains the public key. somebody that can sign the transaction. The input script would be the fulfillment. A good thing about this is crypto conditions are more like Boolean circuits. It's easy to validate and formally verify. You don't have states, you don't have loops. So at any given moment, any party can prove the outcome of a crypto condition because it's just doesn't have any internal state that you have to figure out, trigger, or whatever. This is just practical implementation. You see the coding rules are quite simple, easy to understand. People can flatten the entire condition and stuff like that. In order to have interledger working in a ledger, the only thing you kind of have to provide is the ability for a hold or an escrow. At the time of writing, I was still using the word escrow. I think we migrated to hold. So basically, what we designed for BigchainDB is a hold fully based on crypto conditions. For that, because it's a blockchain, you don't really have something like a state that you can mutate because it's an append-only database. So basically what we do is we locate the funds into a shared address, and a shared address, the hold, can only be released upon an execution condition, which is the fulfillment, or an expiry date. Playing around with these crypto conditions, we figured that if you implement something like a timeout condition, you just need something like an inverter or something to compare to, and then you can create a switch, and the switch is between execution and abort. And it kind of reads like a Boolean logic circuit. It must be stated that if you want to create a switch, it's something more experimental. It's something only interpreted by our BigchainDB nodes, and yeah. So I guess that's all.
So first we'll go for questions to the current speaker. Okay.
Okay.
Thanks. And then now we are on to the open mic portion. So I know Dan had some questions.
So before we get started on these open questions, why don't we have all the BOF proponents come forward so we can all address them.
For the Dan Drutze, for the open ledger, for the payments aspect of it, how do you handle a zero payment? And how do you handle fees along the way, especially for a zero payment? Thank you.
So with the curves, we basically state what amount you need to input to get a certain amount output. And so you can basically solve for the output if you want. So if you have some curve that describes the liquidity between a source ledger and a destination ledger, you can look up, okay, what is the minimum amount I need to put for this to get there and then come out as zero? And I can put in that amount on the sending side. So you could basically make a payment that's purely a message being forwarded through ledgers. I don't know necessarily why you would want to do that. Internet is pretty good at that already, but you can definitely do that.
So you're basically setting your, Dan Drutze again, you're setting the amount you're willing to pay in fees by putting that hold. But how?
So there's actually two ways that fees can be expressed in Interledger. So one is as the spread. So that's just the difference that the connector can take between how much money you pay in and how much they pay out. And so that can be in different currencies, so that could be the same currency, but it could be slightly different amounts. So that's one way for a connector to take fees. One of the interesting pieces of the fact that we're designing a payments protocol like this, as I kind of mentioned this before, is that you can use Interledger to pay the fees to various participants within the system for other interledger transactions. So you could pay a connector, even if they're far away from you. What we're trying to define is a payment protocol where anybody can pay anybody else, even in very tiny amounts. And so another way that a connector could do this is say, it's kind of like could be like any web service where you say, sure, I'll do that for you, but you have to pay me first. And you have to pay me, some small amount. So that's the kind of thing that could be layered on top. That's not right now built into the implementation, but these are the kinds of things that we've been thinking about with this.
Thank you.
Sorry, bit of a walk. Jason Nichols. So in the example that you guys gave in the beginning with Alice paying Bob through Chloe, for any connector, the timeout means that there's always a possibility that Bob has been paid and Alice has been reverted. What's to stop that from being Alice and Alice?
There's nothing stopping that. However, Alice doesn't have any control over the ledgers, presumably.
But she has control over when the signature is issued.
Correct. But if she doesn't issue the signature, that means she doesn't get paid on the receiving side. If she does provide the signature, the connector can forward it.
But it's a timing attack is my point. There's a timeout that I'm aware of when I issue this payment to the connector in the first place. If I wait until the last millisecond before it's invalid, submit.
Right. So
paid twice.
the connectors enforce that there is a time window between the expiry on the left and the expiry on the right. So the expiry dates are basically cascading. And there's a couple other mitigations that Evan alluded to in the risk mitigation section. For instance, if I'm a connector, I might prefer to trade on ledgers that have a dedicated API for fulfillments, so that I'm guaranteed to be able to submit my fulfillment even if the public API is being DDoSed, something like that. So there's all kinds of mitigations you can imagine, and there's a strong incentive for connectors, and by extension, a strong incentive for ledgers to provide those.
Just one more follow-up to that, though. So for the zero payment or micro payment structure, then you have protections in place to prevent that from being used as a DDoS, to prevent the validation from getting back. So again, Alice paying herself twice.
Well, I think, yeah, you're paying money every time you send a payment. And also the rates can, vary with load. So we think that with that, you have enough tools to have some DDoS mitigation.
I'll pay a lot of micro pennies for a $100 million transaction. So you can, if I can invalidate the one at the expense of the other, that was my question.
Right. So I think that gets into some of the more implementation details. But I definitely agree that that's not one of the key aspects to figure out.
Mike Bierma, sort of as a follow-on to that, what is the barrier of entry for a ledger, and what prevents like collusion between potentially the sender receiver and like the sender's ledger?
So there's no real barrier to entry for ledgers because it's more of who's willing to connect to you. So connectors do not automatically open up accounts with different ledgers that just come online. So it's up to a connector which ledgers they want to connect. And so if you want to connect some new ledger to existing systems, most likely you might need to be the actual connector. So we're assuming that all different kinds of combinations of parties could be colluding, but the main thing that we are trying to, that interledger enforces is you cannot be screwed by anybody who is not your ledger. And the reason why why that's a good security model for this is that if you have an account with some ledger, the worst that they can already do is zero out your balance. They can, they can arbitrarily just say, oh, now you have zero money. And so if you want a ledger that has a different security properties, you need to go to a different ledger. And so everyone gets to pick what ledger you choose. So what we want to enforce is the security of sending a transfer, an interledger transfer across many, many hops should be no worse than sending one locally. And if you can't trust your local ledger, then you need to find a new ledger.
Sorry, one more comment on the barriers to entries question. So one place where there is definitely barriers to entry is we have sort of a limited amount of memory to have a routing table. And so for you to be able to get into a large number of connectors routing tables, you have to either be part of some prefix that they already have. So you have to be connected in some neighborhood that's already in everybody's routing table so that the payments can get near you. Or you have to be maybe paying a lot of connectors to be in that routing table, which creates a barrier of entry. So that's kind of something to keep in mind. Is like if you want to be in everyone's routing entry, if you want to be a top tier ledger, that might be a bit more expensive.
Hi, Rich Sauls. So first, I want to say I'm impressed by a lot of the stuff here. It's kind of neat to see a currency protocol that puts the risk on the people who would monetize it and not the end parties. That's probably a first. Obviously, there's still lots of things to be refined. If you're interested in working with the IETF, ASN1 is, you may want to look at things like CBOR and COSI as alternate serialization formats.
Evan doesn't shut up about them, so you're well represented.
He'll find, he'll find a happy home here.
So, and Rich, your comment about the IETF is timely, as I was going to say after you. I want to up level a bit and have people in the room think about and comment on what aspects of this they think, if any, the IETF would be interested in and have the right skill set to assist with. It's, as we said at the first, this isn't working group forming, but we want feedback from the people here about whether this is something we should consider having a working group forming off on in the future, or possibly taking aspects of this. It would be, you know, potential we'd look at the crypto conditions and say that has applicability and we want to work on that, but not necessarily the rest of the system, or vice versa, you know, however that plays out. So I encourage people to come up and share their thoughts on that topic.
Dave Crocker, this is fun work. Your question is an interesting one because the domain of discourse is really something very far out of course, the anything in the application space that we've done. On the other hand, the mechanisms you're using are very much in. You've got all the vocabulary and you talk it well. Finding some way to split those two, the subject matter expertise of payments from all of the transactional and transfer mechanisms. It occurs to me that if you can do that cleanly, there might be a huge win for all sorts of other applications that have nothing to do with payment. Then all that stuff down under is probably wonderful for the IETF to help with.
My name is Andrew Sullivan, and I have learned today that I'm blind. It's cool. So I've been thinking about this very question as I was sitting here listening, and something that I find slightly seductive about this entire thing is that you used sort of models from other kinds of domains without actually doing them. So you've got sort of, you know, two-phase commit kind of on steroids, only with maybe a little bit of loss sometimes, not sure. And you've got the sort of routing analogy without it actually being routing. I will note that in banking, routing is also a term. So we've got like two overloads. It's great. And there's like kind of a hierarchical name, but you don't really have any authority there. So all of these things are bits that I think are cool. And yet I was trying to figure out, well, okay, but do these things fit for the IETF? And then it struck me that one thing that the IETF has to offer that probably other places don't is that many people here, and I'm not sure I'll count myself among them, understand how things can go wrong while you're on the network. And so to follow what Dave just said, if you can kind of carve that out, and I read the documents, you know, your papers and so on before, and then I was trying to figure out, okay, well, how would you carve this? I still don't know how you would do that, but if you think you can, then actually there's probably a focused thing that you could do here. If you think you can't, then I am rather concerned that this is an opportunity to explore for rat holes, and that would be probably a bad thing.
So in terms of this as a project, I think it's pretty obvious that a lot of the design is very inspired by things we've seen here, and that's why they're, you know, familiar to an audience that, as you say, is not payments subject matter experts. I think Evan made the comment the other day that I think we might make a lot of people realize they know more about payments than they think by sort of expressing them in this way. by expressing things in this way, and I think that kind of composability or that sort of layering and so on makes it possible, maybe that we can, you know, pair things off. I think you've hit the nail on the head, though, in terms of, for us, what would be an ideal outcome of this whole adventure for us is people with real expertise in things like routing, who have seen these problems before and can come and say, hey, there was a working group at IETF that tried to do something like that, and these are the various rat holes they went down that didn't work. At the same time, you know, we're doing things with a bunch of extra dimensions in some respects. So you kind of, I think the question earlier was very pertinent. It's not like shortest path. We're not just trying to get the packets there as fast as possible. There's, you know, routing decisions are taking into account reliability, cost, and a whole bunch of additional dimensions, which are quite interesting as well. And hopefully we'll play with things and come up with things that apply to Interledger that people go, hey, how could we apply this idea back into data transfer or data, you know, protocols that are more traditional at the IETF. So it could, you know, it could go both ways.
Yeah. Dave Crocker. We need a PKI. Eric Scorla. Yeah, I guess I'm less sanguine about the IETF taking up this kind of work. I have a number of concerns. I think the analogy to routing is pretty shallow. Frankly, I think the analogy to IP is pretty shallow as well. I mean, sure, these are stored and forward messages, but that's where the analogy stops. The routing systems that we developed are not designed to operate in adversarial conditions where people are lying about their properties. We have no real practice here of knowing how to analyze those kinds of, the game theory required to analyze those kind of systems. The cryptography you're using is, I mean, that's something we do have the experience to standardize. You're using relative elementary cryptography, but the problem in those things is always the contact to the actual operational domain, of which we have 0. So, I guess maybe there's some piece we could maybe as the, you know, as the financials get further down. I mean, I guess I would say several things. One is if you show up with a passel of people from the financial industry who want to work on this here, then somebody would have the domain expertise. But absent that, I don't think we do. You know, the financial industry does have all its own crypto shops, primarily X9, which is where things actually typically happen. So the extent to which you want to standardize the crypto pieces, that's a natural place to do it. So I mean, you know, I guess, you know, maybe there's some piece that gets hived off and shoved here, but I think you'd have to have a system that had a sort of a bigger story about where the rest of it was done before that would be something we could really take on.
I actually want to address two of the things the previous speaker had said. Jason Nichols, by the way. I think coming from the financial industry, one of the things that's kept us away from, and I'm now currently with Time, obviously, so I'm no longer with the financial industry, but I was previously in the New York Stock Exchange. What kept us away from meetings like this is that there was limited relevance. So no, we didn't express interest because there was nothing in which to express interest. So now that you're kind of bringing that to the table, I could see a lot of people that I know being very, very interested in seeing this kind of standardization. And I also see that it does touch on a lot of stuff that I've seen, at least with GGIE content networks, cost of network that they just talked about in the WebRTC meeting. So there's a lot of factors here that relate at least to the application stuff I've seen, but I can't speak to what the IETF does because I still got the little ribbon too, so.
Dan York, first I'd say thank you for bringing this here. It was very interesting to listen to and read that. And I also will just say, as somebody who does a lot with presentations, I personally enjoyed your presentation style. So thank you for doing that way. It was very descriptive, very helpful, and certainly made a lot of sense out of what you had put it there in the text. I guess one comment that would make, just as far as you were asking about, you know, insight from other things, I will just say that as I looked at this, my initial reaction when you put up there was, the minute that you have something that looks like a domain name, it usually gets winding up showing up in other places as if it's a domain name. So I would just say there be dragons in that whole space, because we've seen that in other areas, in other places where people have implemented things. They've done something. They've done it in saying, well, it's never going to be used. like a domain name. It's completely separate. It's going to be off doing this space, so it's no worry. And then it's later come back to somebody said, oh, well, but we could use this in this browser or something, and all of a sudden it becomes resolved like a domain name, and you get all sorts of collisions and really bad things happen. So that would be my one bit of feedback on that from what we've seen. As I see people queuing behind me on that. The other question I had was, you've mentioned a couple of different other groups, or I guess, where do you see this work evolving? You mentioned the W3C group, you mentioned some other pieces. Like, you're here at the IETF, but are you looking to, what part of this are you looking for us to be involved with versus other groups, or is that still all unclear?
Yeah, I think we're here to find out about that.
Okay.
One part that, in my own opinion, I think would be most interesting is, and that's why we broke it out, is the crypto conditions stuff. I also agree with some of the previous commenters that there might be other things that come out of this work that have more general applicability that we can collaborate on. I think where the work will ultimately happen in terms of the ILP protocol and a lot of the finance specific things might very well be like a new organization that we help bootstrap.
Which is my last question, I guess, is just, you've mentioned a couple of reference implementations of various pieces you're working on. Do you have a sense yet of what other payment networks or others might be interested in this?
Yeah, so in terms of adoption, we kind of break it down in a number of different categories. So we have sort of cryptocurrencies, where it's pretty much up to anyone who's willing and able to do the work to integrate. There isn't really any buy-in that you need to get. So there we've gotten some interest from Ethereum, Bitcoiners, but we very well might just put the resources into it ourselves to integrate. There is a lot of interest from financial institutions, because that's our sort of core area of expertise. We have 50 banks that we're working with. They all looked at ILP saying we want to upgrade as soon as possible. We want this to come out as soon as possible.
Adam, you're about to give
Someone's
us
sitting on the remote.
Yeah. Slow down there.
I think there was a slide that addressed this, but we have like 200 slides, so it's going to take a while.
Okay, well, no, you were just giving me a little bit of a seizure there for a moment. Okay. All right.
Seizures, man.
Okay.
So we got a lot of interest from banks. We have some interest from central banks. So, I'm not going to be able to name names here, but
sure.
Basically the interest comes from similar reasons as to why central banks were interested in IP back in the day, was reliability and like survivability. So like, this is a network where you don't have this central switching place that could get blowed up. And so we've gotten some interest from that area, and as well as just better resiliency against failures, because like today in the wire world, when something fails, you don't get any feedback. So I would put that in the second bucket. And then sort of the third bucket is sort of tech companies and fintech companies that are like wallets, those sort of things, like the Venmos of the world. And I think, yeah, exactly, like big change. Two of the guys the two companies that presented the first real money payment, GateUp and Bitstamp. There's a lot more like Bitcoin blockchain type companies out there. So I think for them it's attractive because it gives them greater reach. So they usually have very localized reach. And then they can use something like a cryptocurrency for liquidity, but that doesn't mean that it's a good user experience to actually send a payment from them to someone else, because you have to go into Bitcoin, and you have to have a Bitcoin client, and you have to go out of Bitcoin and so on. And this could make that a lot smoother. So those are sort of the three areas where we think that there's value. Maybe also on the other side, so this is kind of on the foundational side. On the application side, there's a lot of protocol designers that want to build payments into their applications. And today you very often see like a demo which has like powered by PayPal at the bottom, and that's probably not great. And so for them, this could be an abstraction layer so that they can build something neutral into their application and then still support different providers underneath.
Okay, thank you.
Okay. So if we may ask one, so it sounds like there was some interest in maybe looking at separating this a bit from, seeing if there is interest in separating some of this out from just purely payments and currencies. So one question we'd like to ask and for you guys to think about is if anyone here, who here is willing to help with that sort of, to help them with that kind of split? Okay, there's a number of hands. Very nice. Okay.
I saw at least 3.
Right. And And then as we go on, we'll just think about which of these things we want to start with, whether it's for the bot proponents themselves or our participants here.
I just want to add, sorry, Matt, to Stefan's last point. So there is going to be very likely some work at W3C as well, but it will be very much in the higher level stuff, the sort of end user pieces. So we've talked a bit about, the fact that there's this core interledger protocol, but there'll be stuff on top where you do things like define the condition and, identify the ILP address and so on. So that level of stuff, there's a very good chance one or two of those would be defined in the web payments working group at W3C. So that's ongoing work.
Jari Arko. So I just wanted to come here to the microphone and say that I'm interested in this work. Thank you for bringing it here. I'm not totally sold on all the design decisions that you guys made, but this is not the place to have that discussion. Although we had some of that obviously during the session already. But I also wanted to sort of respond to what Eric said earlier about how well this fits to the IETF, and we don't really have a definition of what work is allowed in the IETF. It's really about there being a community of interested people, the developers, the users, the businesses, and when we have that's the core, that's the key thing. And of course, there needs to be some connection to the rest of the communities that the rest of us can read, what the specifications say and point out issues. And there's you've seen some of that actually, the crypto guys and the DNS guys obviously immediately coming to the microphone explaining that no, we can't do this. So I think this would fit well here. Thank you.
Actually, if I can do a follow-up question based on that, we heard someone say, the finance industry isn't here because we're not working on finance. I'd be curious to hear from you if, looking at these bodies that we're talking about up here, if you think that they would be likely to start showing up if some aspect of this work were done in the IETF, based on your conversations with them so far.
I think it's difficult to say. It's a pretty non-traditional place for those kind of people to be, but who knows? I guess we would have to. Today the development of the standard is being done by interested implementers, effectively, which is, I guess, the way stuff's done at IETF. But those implementers are not traditional IETF participants. So that's where we are today. It's early days. I don't know.
That's a good answer. Thank you.
This is Richard Barnes. Oh, go ahead.
Sorry, I would add to this, just there's a lot of willingness perhaps, but there's a big sort of cultural gap and just process gap. Like the way that things are done at ISO, as we all know, is very different, and that's kind of more what financial institutions are used to. So
we're proud of that.
There'll be a lot of education. Yep.
It's a feature, not a bug.
Yeah, this is Richard Barnes again. I wanted to express a slightly more optimistic view than Ecker about the possibilities for overlap. I mean, I think there is, I don't think the analogies to routing and IP are entirely shallow. I think there are some lessons to be drawn from experience with distance vector protocols. And, even though BGP doesn't perform, isn't designed to work well in an adversarial environment, is used in an adversarial environment every day, and people lie in the protocol every day. And there's, we don't always have solutions to these sort of problems, but at least there are people around here who know where some of the bodies are buried, and at least know what the problems are. So I think there's some useful, maybe at least, even if it's just intuitions, I think there's some useful stuff to be given here. I think the sign that people were reacting to design choices here, going, ooh, certain things, oh yeah, that makes sense to other things, is an indication that there is some overlap and there's some commonality to what we're talking about here and what people have experience with. That said, I think in order to really drive this into something like a working group or to figure out what there is to do where, it would be helpful to have a little bit more in terms of architectural breakdown and understanding what the kind of unitary pieces are that make this up. It feels like there's a routing protocol here, a locking and transaction protocol here, a crypto condition layer here, it would be helpful to understand, what those pieces are and how they fit together into the overall system. And, ultimately, you kind of want to take those and piece them out to the various organizations. Maybe some of them end up here, some end up W3C, some end up at ISO or ANSI or what have you. But to make that analysis, it would be helpful to have maybe one more layer of decomposition in terms of the functions we've got here.
One quick comment on the analogies, that's not something that we've done for PR purposes. That's literally something that, like, for technical reasons, these comparisons come up, and usually the way that we get stuck with some technical problem, how do we solve this routing for our reference implementation? And the way that we solve it is by reading some RFC from the 80s that works perfectly for our use case. We just have to tweak some things. So it's not necessarily the protocols today that have gotten very use case specific and very tuned and very nuanced, but like some of the older ones that are a little bit rough around the edges, but like solves similar problems that we're trying to solve. Very informative for us.
Eric Rescorla. Dave Crocker again. I'm glad he said all that. When I listen to these kinds of comprehensive presentations, most of the time the question is, do they pass a smell test? And the answer is no. They have lots of acronyms and fancy words, but there just doesn't feel like substance. I didn't have that reaction this time, and I really usually do. That doesn't mean, like anyone else, that I differ in disagreeing with this choice or that choice. My feeling in exercises of this kind of evaluation is, does it pass a smell test? Are there things that are likely to need improving? If the answer to both of those is yes, then there's work to do rather than just rejecting it outright. I should mention, by the way, you've read lots of RFCs, but I don't think you've been to IETF meetings before. You are getting an extraordinarily friendly reception. We've had other groups come in, nothing like this reaction.
I know, I'm really disappointed. Like, come on.
You did get a taste of a little bit. You should look forward to more. So each of the pieces where you invoked an IETF-related technology and then applied it felt like a reasonable kind of application. Again, whether the details are right is sort of irrelevant to this discussion, other than whether there's work to do, and there is. But it felt to me like the piece that you're doing that other than maybe the DNS, that feels different, but within the workspace of the IETF, this is a multi-party transaction system. DNS does a version of that, nothing like what's called transactions. And that might stretch us, which would be good for us. And so my feeling is, and by the way, we've had some efforts trying to do application level generic mechanisms, and we haven't succeeded at that very well. So there's a chance, this is dangerous to suggest, but there's a chance we may actually get something out of this besides you guys.
So just real quick, we are like 5 minutes from the end of the session, and I want to make certain everyone in line has a chance to say things. So please keep it brief. And also, before we run out of time, I wanted to point out that we would like to continue this conversation. We don't have an art list yet, but I think we can do this on Apps area until that's set up. Sorry? Okay, Alyssa's going to correct me. Hold on.
Alyssa Cooper. We have an Apps Discuss.
Yes.
I'm sorry, that's what I meant. Apps Discuss.
Which is going to be converted to art in a few days, but we can start it on Apps Discuss, and everyone from Apps Discuss will be subscribed to art. Thanks.
Thanks. Okay.
Sorry, Jason Nichols again. I just want to say I had a little bit of concern about the separation or trying to break it down into the atomic parts, and that the one thing that I was concerned about with your presentation was that the exchange rate portion seemed a bit hand-wavy at times, where the demand curve was alluded to, but not really kind of formally described. And I do understand that that's something that's probably not going to be in the scope of what the IETF does. But how much do you think that separating these pieces out could degrade the individual functionality where, you know, the IPR or the ILR, the Interledger Protocol, ILP, I can't do acronyms, I'm sorry, would not work without those bits.
Yeah, so I think the main thing that we're trying to do is we're trying to make it so that the routing can be iterated independently from the packet format. And the reason for that is because we want senders and receivers to be able to stay the same, even as you change the routing among the core group of nodes. And yeah, I don't want to say too much more than that because of time constraints, but if you want, you can come up to me afterwards.
Yeah, Eric Scrolla. I feel like maybe we're arguing about this fine point too much, but the routing, as the routing analogy, we have only the barest notion of how to do routing in the presence of any kind of adversary. And right now it's a debacle. And the only reason we have anything that works at all is by making the most trivializing assumptions about who's authorized to speak for who. And the idea of extending those to a system like this is something with any concept of how to do. It's just comically wrong, right?
I would say that I don't think anyone is proposing taking existing routing protocols and extending them.
No, what I'm saying is it's a completely unsolved problem, but IETF has no experience in.
Yeah, fair enough.
Thomas Stadium Mozilla. I just wanted to say, I mean, when I watch the presentation, I see many connections to Bitcoin in particular, right? I see you have your smart contract thing. Crypto.
Can you get a little closer to the mic? Sorry.
Which is, you know, it reminds me a lot. There's a Bitcoin script revision called Bit 114 Merkleized abstract syntax trees. It looks very similar. There's you had your Oracle thing, which is very similar to the work that's going on in Bitcoin for things like the pseudocode script and the things that use external verifiers. I didn't see any references to those in the draft. I saw more in the presentation, so that was good. But I just want to make sure we reference like this. I'm just not sure also that the IETF has people that are experiencing those previous things. So I would really like to see more people that have the experiments implemented those things previously.
Yaron Sheffer, I would love to see this work being done at the IETF with one caveat. There's obviously a lot of architecture layers on top of what we saw today. I think it's important that we understand what they are and that they are worked on in a manner that's consistent with the IETF. So even if not at the IETF, it's some sort of open forum. Otherwise, we here will be working in the dark. It doesn't make any sense.
Yeah, I mean, the only comment on that really is our work process to date has been completely open, and that's certainly our intention going forward. Everything, all reference codes, open source, all discussions on public lists. Yeah, that's certainly from our perspective, that wouldn't change.
Well, we could spend some more effort in making a forum and opening up discussion a little bit more online. Yeah.
So as far as the IETF work goes, as we said here, we can continue this on our apps discussed list. I've put a link into our Jabber room at least. I'll make sure you guys have a link to that. I've also made note of those people that raised their hands. I'm willing to help, so don't be surprised if I reach out to you later. And is there any final thoughts from our sponsoring AD?
Alyssa Cooper. I'm glad that we scared you enough ahead of time so that this feels like it was successful. But I do think, I don't know, sitting there a little bit, I wonder if one of the things that's coming out of this, which is not really, I think, a typical outcome, is just that there may just be a few people in each of these different areas who are here who, even if nothing else happens, they have made a connection with you potentially, and vice versa. I think you know, a lot of people's eyes kind of opened up to some of the things you're working on. So that I think is a good outcome and a good use of this time, even if nothing else happens. But we'll keep the discussion going as Matt says. So thanks for putting in the effort.
Right.
Yeah, and thanks again for the time. We appreciate it.
If anybody hasn't signed the blue sheets, they're up here. Please come up. Otherwise, I believe we're done.
Go enjoy Bits and Bytes.
Thank you.
That went way better.
Thanks. That. So Matt,